So today, by what I heard yesterday, maybe we're going to be talking about the universe and bringing it around and seeing how it fits in with AI and moral technologies. So, with no more speaking from me, I'd like to welcome for the last day of Moral Technologies, Nick and Orpelas.
Thank you, Matt. Thanks, yeah. Well, thank you, Matt. That was a pretty concise summary. So I see that you got skills that you can bring to your social entrepreneurship practice. You can mix ingredients and manufacture them. Anyway, I'm really sorry I missed last night. I was really tempted to, I could hear the laughter, the jokes, and I'm very near the place, and several times I wanted to get out there and join, but I was, wow. I mean, it was a conflict, inner conflict. But then I had to make sure that I was prepared to synthesize the various things here. So I'd like to start with something that really happened. I think shortly after 9/11, but at the height of the debate on the World Trade Organization. And I surprisingly received a letter that was thrown around to a certain network of civil society around the world. It was an email from I think if I recall right, either the Prime Minister or the President of France. I don't know which one. And the letter was asking to have a kind of conversation with global civil society leaders. And somehow I was in that network. But for me, the interesting thing in that letter, which has a lot of relevance to what we're dealing with today, is the French Prime Minister or President said, do you want to live in a society that's really just a market economy? I'm referring to the WTO. Because the WTO was planning to commodify all areas of society, right? From the market, commodifying the state, and then commodifying culture, basically civil society. Or do you want to live in a society with a market? Okay, so these are two different pictures. The market is the society. Do you want to live in a market society? Or a society with a market? Okay, so I thought, oh, that's really interesting because this is what global civil society was saying, that the market cannot be the end all of human existence. In other words, like economics cannot dictate how the state or how culture should function. That was a debate then, and the WTO tried to convert the whole world into a market economy. Because I already mentioned, I think, in another context, the Philippines had to change 32 laws because it became illegal under the WTO. In fact, the WTO said, that is now, the first Director General said, this is the new constitution of the world. So all legal systems in the world that are in the WTO have to align themselves with that. So that was the reference that was at the background of why the French Prime Minister or President wanted a meeting with global civil society. Because there was also a conversation on GATS, the General Agreement on Trade in Services, which would commodify education. At that time, the WTO, the World Trade Organization, was looking at education as a $6 trillion industry. Okay, so it's, it's an industry. Not the drawing out of the full human being, okay? And so it wanted to commodify even culture. So that was the WTO, so that was the question. Do we want to live in a market society or a society with a market? Okay, so it's the same with the AI. The reason why I had to bring in different aspects from different scientific disciplines, and I will add another one this morning, is because is AI the world, or is AI in a world, contextualized by a larger world? So, and therefore, if it's just part of the world, because I don't think you can digitalize nature. Of course, there's debates going on, but there are some ratios in nature which are irrational numbers. They're not simple digital numbers, including the way the planets are going, including the growth of plants, and so on. But there's an attempt to digitalize it. So if you digitalize something that by its very nature is not digital, so what would happen? Right? So the question is AI the be-all and end-all of human existence? Or is it a major part or an important part of human existence? This is the question. And so when we explored natural evolution, we saw from the planet Earth perspective, how it was very difficult for life, or almost impossible, or basically impossible, statistically, mathematically, to come out from non-life, and similarly with the brain, with consciousness. So there are gaps. So it seems like there are if you follow conventional science to its very end, there are actual gaps. There are gaps in the process if you think it through. And interestingly enough, these gaps, we might expect to see this gap also if we study now, if we take a look at the evolution of planet Earth. This is the Earth. And we've just examined life, basically, consciousness, to some extent, reflective consciousness, reflective thinking consciousness, and out of which emerge a self, right? If you take a look in terms of natural evolution, if you look at it from the Earth point of view, it's just this sequence. And many of these sequences, especially these four sequences, okay, have all gone into a kind of dead end. Not being able to create life out of non-life, not able to create consciousness out of life, and so on. So we will go back to this because this is a lot of implications. So the question is, so what happened before planet Earth? Maybe that would shed light. Okay, so you have the Big Bang. The beginning of the universe, of the physical universe. And of course, there are many other steps here that we will see later on. But the question is, maybe the answer will lie there. Okay, I must give the impression. I don't want to give the impression that science was developing that way systematically. So the different scientists were biologists interested in life. There were physicists, chemists interested in properties of matter. So, brain scientists and psychologists interested in consciousness. They were dealing with their specific areas. And there were astrophysicists that were concerned about how the universe functioned. Now, it's very important to take a look at what is the current picture of the universe. Because basically, what we believe the universe to be will deeply affect how we believe what planet Earth is, its purpose, the beings in it, and so on. And we already have a historical example in the case of Copernicus, right? The Copernican revolution, which said that the sun does not revolve around the Earth, but basically that the Earth revolves around the sun. And then Galileo actually creating a telescope to actually see these movements. And it was considered heretical because it overturned the social order of the Catholic Empire. Okay, so ideas about the universe and what it is are very revolutionary. That's why it's called the Copernican Revolution, and then ultimately Luther came and, the whole history, right? But it all started there because the Catholic Church had built a model of their social system based on their conception of the universe and the layers, right? From the point of view of planet Earth, right? So that's all part of history now. And Pope John Paul II, a few years before he died, in the early 21st century, apologized to the world for the Inquisition. I mean, heresy, people getting killed because of heresy. And then he also apologized for the way the church treated Galileo. So in other words, he acknowledged that that was not an appropriate treatment of a scientific question. And then the second thing that he mentioned, which at least ended the debate in the Catholic system stream about creationism and evolution, was that he made a statement, which is in a sense interesting, because he said, God did not create the world according to how some people understand the Bible to be, which is saying 6 days, creationism. God created through evolution, but not the kind of evolution that is the Darwinian evolution. It had a more spiritual, and he didn't give details. And so it's just very interesting, the kind of historical adjustment from a very powerful institution that has affected Western civilization. But the point here is that our ideas about reality will affect how we organize the world, how we behave as human beings, and so on. And one of the most powerful aspects of reality that actually govern us is our implicit, tacit assumptions about what the universe is. And therefore, what it's made of, its structure, and its... Okay. So these we're headed this morning to shed light on this other field, because later on it will also shed light on the mystery of the origin of life, on the mystery of the origin of consciousness, and so on. Although that was not the original intention, it was just a study of the stars. But then all of a sudden they were finding some really mysterious aspects about the universe, which could then shed light to what the biologists were having dilemmas with, to what consciousness scientists were having dilemmas with, or brain scientists, and so on. So we're going to expand to using the, you're doing it with me, so they will expand. And then we're going to contract. I mean, we're going to expand to the universe and see then how that now looks back when we go back with a certain picture about the universe. Okay, so I also want to acknowledge that there was I was given a letter from a group over lunch that had the question, is information the new God? Okay, I'm gonna, as we shall see, that question is sort of bordering on something that we'll take a look what that really meant. Okay, after understanding the story of the universe. So I would like to start with a fairy tale. A fairy tale which was subsequently used as a metaphor or an image or a word in astrophysics. And I think I already mentioned it the other day, Goldilocks, right? You're familiar with the Goldilocks, the fairy tale? Okay. So I won't go into the details. It's just about Goldilocks entering a cabin of a bear family and she was very hungry, So she tasted the porridge of Papa Bear, which was too hot, the porridge of Mama Bear, which was too cold, and the porridge of Baby Bear, which was just right. And that's what she ate. So apparently, they're finding out that the universe is constructed that way. There's a lot of Goldilocks zone in the universe. If the moon was a little closer, stuff like that, if the solar system like this, if the force of gravity was not in the Goldilocks zone of certain values, we would not have the universe that we have today. Okay, so they call this fine-tuning. Okay, fine-tuning. And so NASA and associated astronomers have been very active trying to find Earth-like planets in other solar systems. And I said the other day, they have discovered over 1,000 already. In other words, it's just near the sun, their sun, not too far away, maybe life can be there. Okay, so, okay, fine-tuning or the Goldilocks zone. And by the way, it's all connected to this concept of anthropic principle, which, by the way, is non-controversial in astrophysics. Everybody talks about this. Everybody acknowledges it. And the question is, how would you try to explain the structure of the universe? Because it's very precise. It's very precise. Okay? So, the anthropic principle is saying that, it asks this rhetorical question. Why is the universe structured the way it is? And they give this rhetorical answer, because we're here. So you can interpret that in several ways, and there's the huge debate on the different interpretations of that statement. In other words, the universe is structured so finely that any change in the parameters of the universe would either not result in the galaxies that we see today, or the human being would not appear. So that is what's called fine-tuning. I'll just give you a few examples of fine-tuning. We're all familiar with gravity, of course. That's why I'm going to use that example. And the fine-tuning in gravity, if it becomes too strong, then we will not have the universe as it is today. The universe would have turned into a giant black hole in 1 million years. According to scientists who've done the calculation. On the other hand, if the gravity was too weak, then the galaxies will not form. So the force of gravity is just right. Okay? It's a very small deviation. What is that deviation? The deviation is that, okay, it's very small. 1 in 1 followed by 59 zeros. So you remember yesterday what was said about the figure that is, right? The limits of probability. So beyond that, if a figure is so fine in terms of probability, so low, it's 0 probability. In other words, chance did not do it. Okay? So the figure of 10 to the minus 59 for gravity okay. By the way, I'm just going to use a few examples, because if you want to read the book, there's a whole thick book on this whole thing of the different values, and I don't have time. So it's just to illustrate the point, right? So In other words, this fine-tuning of gravity is not explainable to chance. It didn't happen by chance. Okay? And then I'm going to go through a series of these things and then come out with the two positions that have split astrophysics in trying to understand what's going on. But first we have to understand they're dealing with an improbable universe. The universe is, the structure of the universe and its processes and its laws are full of these kinds of fine-tuning, which shocking, when it was first seen, it was shocking everybody. Okay? Wow, this is such fine-tune that chance could not have done it. Okay? So the next one is what I mentioned yesterday, dark energy. The fine-tuning is that it cannot go over certain values that is connected to 1 in 120. 1 followed by 120 zeros. Because if you write it like that, right? So 1/2, right? Or let's say 1/4, 1/8. If it's 1 over 1 followed by, it's a very small number, right? Okay, so yeah, 120 of that. You cannot even pronounce it. So a trillionth of a trillionth of a trillionth of whatever it is, right? Deviation 1 in a... So...
And so, are you saying that when the universe was created, gravity and dark, the chance of it being as it is was those numbers?
Yeah. In other words, the value, because if you deviate from this a little, if this became, let's say, 10 to the minus 58, right? Or 10 to the minus 60, well, the universe as we know it will not be around. Yeah, Luis?
But I don't understand, isn't any universe improbable? So why is ours,
I beg your pardon?
isn't any kind of universe improbable? So it's maybe ours was an accident. It doesn't mean it's oh, this is so unlikely it couldn't have happened, because something had to happen.
Right.
So
Yeah, we're going to go and answer that question. And this is where it's leading. Because the fact is we're here. Something did happen, and we're here. And that is the undeniable fact. Right? So when we look now from here, we're going to look back at this, as the structure of the universe and see these values, and they're all impossible. How did it come about that we're here? Given all of these impossible, improbable aspects of the universe. Okay? Okay, and then, just as a final example, entropy. So entropy, you know what entropy is, right? The second law of thermodynamics. Okay. From low energy to concentration of energy and dissipation, right? Towards dispersed high entropy states. The conventional belief is that in 5 billion years, we're all finished, physically. But maybe with AI, we'll be in another planet. But as far as this sun is concerned, the solar system, the sun, it will run out. It will go into a state of high entropy. And goodbye, planet Earth, right? I mean, that's the thinking. And that depressed a lot of people, by the way, several decades ago. What's the meaning of human existence, blah, 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 I mean, etc. Anyway, so what is the entropy? What is the probability that after a Big Bang, we have a low entropy universe that then develops into a complex universe the way it is right now? So Roger Penrose, the mentor of Stephen Hawking, and became the author of the Hawking-Penrose black hole theory of the universe. we'll see more about Stephen Hawking because he's like the Einstein of the 21st century, right? Many people give him that label. Roger Penrose calculated it's 10 to also pretty high, right? This, as you can see, I'm choosing these examples because they are all over the limits of what is considered probable. Okay, what I'm putting up here is what do we call this? Non-controversial. Okay, but I'll point to you what the controversy is. Okay, the controversy is that, okay, it's very clear. So there are two sides right now in astrophysics. So how do you explain all these improbabilities? That's why it's interesting that one side, basically the theistic astrophysicists, right? So this is now splitting the astrophysics community. So you have the theistic astrophysicists who are saying that, in answer to your question, Louis, since this is not due to chance, there must have been a kind of intelligence that encompasses the entire universe and guided its evolution for 13.7 billion years, right? This whole thing is about 13.7 billion years. Some sum it up, let's say 14 billion. But instead, if the causes that we know that exist in the world, whether it be quantum physics, whether whatever kind of forces that we know are producing this kind of improbabilities, there must be a source, an intelligent source that created the whole thing, designed it, gave it a purpose. Okay, that's one side, right? So in a sense, it's very interesting because science has rediscovered God. I'll give some quotes, right? Because in the 19th century, mathematics was such a situation that I think it was Pascal who said, give me the velocity and the location of any particle in the universe and I'll tell you what will happen in the future. There's no need for God. God is dead. So that was the position, right, in the 19th century. So now, of all places, astrophysics scientists are really discussing about how then do you explain this thing? Okay, the other explanation, okay, that's one explanation, is theistic because it now believes that there is a creator, intelligence that oversaw this whole process, because there are many non-random events here that are high in probability that are occurring all the time. Okay, so, yeah, please.
I got that same thought too, that if the dice had just fallen 1/trillionthly different, we would simply have 1/trillionthly a different universe. Like we might all be transparent, for instance.
Okay.
There could just be, we'd still be going, oh my God, how could this come about? But
Right.
it is just what happened to have come about.
Right. Now, okay. Yeah. Okay, we have the multi-universe theory, which is more the atheistic astrophysics. Where we don't need God. There are 10 to the 520 universes out there. So that's a lot of universes, right?
Could there be more?
Maybe even more, yeah. But mathematically, that's the number. Mathematically, that's the number. So therefore, what seems to be improbable in this universe, if you look at it from that perspective, is probable, because there are 10 followed by 520, and this one is only 123, right? So there are even more possibilities for that kind of structure to take place. Now, the only thing is that this theory of the multi-universe, has been criticized very heavily from many different directions, and there's no single proof that it exists. And it violates a tenet of science itself. Okay, you know Occam's razor? Introduced no less than by Bacon, right? Or no, Bacon used this a lot, and modern scientists use this a lot. Occam's razor is that if you can explain something with simpler stuff, why use a complicated theory to explain the same thing? Like positing the existence of 10 to the 500, incredible number of universes, which there's no single evidence that it exists. So when it's simpler to say, the evidence is pointing that there is an incredible vast mind that has actually been active from the beginning of time that created this. Okay, so that's where it is, right? Now I'm going to give you some quotes because this is where it is right now, and it's now a matter of a belief system, right? There's a very strong evidence for this side. There's still no empirical evidence for that other side. Even the mathematics are being questioned. And so there's some, here. Because the implication is now starting to dawn. Okay. Here's what British astrophysicist Frederick Hoyle, who's also famous for some of the principles and laws in astrophysics. He makes a remarks. Common sense interpretation of the facts suggests that a super intellect has monkeyed around with the laws of physics. Okay? He's played around with the laws of physics. Because it's very interesting that at the beginning of the universe, the point of singularity, the physical laws that we know today are not the same. In other words, the natural laws that we know exist today break down in the 10 to the minus 37 seconds of the Big Bang. You know, there are PhD doctoral degrees in astrophysics given for the first 5 seconds of the universe. It's a very involved area of astrophysics. What happened in the first 5 seconds of the universe? Yeah, Brian Swimme is one of them, right? The New Universe Story. So take a look at Brian Swimme. I'm not pronouncing his name properly. But anyway, this is astrophysics is one of the most active fields of science today. And its current level of instrumentation is so far advanced that, it's like they describe, one of the scientific articles described the instrumentation that can measure actually the whisper, this is the language, quote, the whisper of a hydrogen atom at the edge of the universe. But that's literally true, because spectroscopy is able to measure emissions, right? So anyway, it's a booming field, and so there's a lot going on there. And then Robert Jastrow, he's the head of the Goddard Institute for Space Studies, has referred to this fine-tuning as the most powerful evidence for the existence of God ever to have come out of science. Okay, I'm presenting the theistic, by the way, there are also some conversions in the process, right, as we shall see, because the evidence is too strong. I already mentioned Francis Collins, the head of the Genome Project, who wrote the book, The Language of God. Here's an interesting opinion from a former NASA cosmologist, in other words, the one who's an astrophysicist, basically, Ed Harrison. And he says, here is the cosmological proof for the existence of God. The fine-tuning of the universe provides prima facie evidence for deistic design. Deity, deistic. Okay, kind of. Take your choice. Okay, so then he spells out the current position in astrophysics. Take your choice. Blind chance that requires multitudes of universes. Okay, that kind of figure, very big, large amounts. Or design, which requires only one. Of course, the choice, you have to make the choice. Then he makes a very interesting comment. Many scientists incline towards the design argument, the theistic argument. In fact, some of them started converting because the evidence is just too powerful. And by the way, I'm going to, towards the end of this talk, probably the second part, we'll start to take a closer look at what this all implies for artificial intelligence, which is the main topic, right? So, now what does Stephen Hawking say? It's very interesting because his book, A Brief History of Time, of course, is very famous. Everybody knows him. He was one of also those that I quoted earlier that is concerned about the future of AI. So it's very interesting. Remember the quote that he said? And it's connected to transcendence. He said people should take movies like Transcendence very seriously because if you don't handle the AI properly, this might be the greatest mistake in human history. So here he is. And by the way, it's very interesting because now he's trying to introduce a theistic framework that's now more and more scientists are beginning to see. It has to be there in order to even do science. Whether you're atheistic or atheist, there's a certain presumption. I'm going to touch on that. Okay, Stephen Hawking says, towards the end of his book, the overwhelming impression is one of order, talking about this universe, right? The more we discover about the universe, the more we find that it's governed by rational laws. Okay, so this is very important. And if you know the history of astrophysics, many of these discoveries were preceded with mathematical hypotheses. In other words, astrophysics is basically a deductive science. Okay, we were saying, well, many of the sciences on Earth are inductive. You cannot do experiments with the universe, right? All you try to discover is what it is. So, for example, the theory of black hole was, 30 years of mathematical theory until it was empirically discovered. The background radiation of the Big Bang was already posited together with the theory, but was only discovered empirically in 1989, many decades after the theory. And then the people who discovered them were awarded the Nobel Prize in 2005 or 2006. So do you see the gesture that I'm referring to? There's mathematics, there's no empirical perception, and then you access natural law. So scientists are beginning to ask, why is that the case? Right? It says something about the nature of the universe and about the nature of human consciousness. Why can we, with our reason, in a sense, perceive through mathematical thinking something that we cannot perceive with our physical eyes? Yeah, so almost every major discovery of astrophysics has that nature. Mathematics first, no perception. And then they try to create the instruments to measure that, and then they succeed in measuring it, right? So perception comes last. It's the opposite in Earth, right? Start with perception, think about it, and then come to certain conclusions after experimental procedure. Yeah? And so, that is the situation with mathematics, right? The most famous example, of course, we all know, and again, with apologies to, to Jiro. Einstein's, right? Einstein wrote this equation. It's a very famous equation that's taught all over the world, right? Okay, but if you ask human beings during the time of Einstein, did they see atomic bombs exploding? No. So the atomic bomb was not a perception, but the human mind perceived it and started creating it, and it became a reality. Out of accessing specific laws in nature. So scientists are asking, why does reality have that structure? Why is it rational in the first place? So we will see that it's coming up here more often because it cannot be avoided. Even if you do science, you have to assume that the world is rational and it's governed by laws, right? So now, and then continuing the Hawking, I'm just trying to explain. The more we find that it is governed by natural, rational laws. So he's referring to this property that mathematics first, and then discovery. Yeah. That's the case of the famous mathematician, last example. An Indian mathematician who was enamored with an equation. Forgot the name of the mathematician. He's Indian, it's too long. In fact, one of the space facilities is named after him. He was brilliant, and then his colleagues were telling him, and here we come to something really important actually. He said, "You're a brilliant mathematician. Why are you wasting your time on this equation which has nothing to do with the physical world? Why?" And then you know what his response was, which in a sense shocked his colleagues. Well, because it's very beautiful. Okay. So here we're getting a kind of hint. And then later on, several years later, they finally found out that his equation was the equation of the shape of the galaxies of the universe. Ellipsoidal shape. Okay, so in a sense, we're beginning to see that to access objective reality that is not seen by the physical eyes, our mind has the power to do that. Thinking is not just an organ for cognition in the ordinary sense. Thinking is an organ of perception. Okay, I think I'm going to go back to that because to a certain extent, you are perceiving these things, right? And you don't see it with your physical eyes. And then you create, when they created the Hubble telescope, then they finally saw the galaxy, right? That's when they said, oh my God, this guy was onto something after all. Okay, so here's the Stephen Hawking quote. Even if there's only one unified theory, okay, and I mentioned about the search for the unification theory of the universe. Then he says something interesting. It's just a set of rules and equations. Then he asks the question, what is it that breathes fire into the equations and makes a universe for them to describe, for the scientists to describe, right? For them, the scientists to describe. And why does the universe bother to exist? So in other words, basically saying, do those equations have any connection to reality at all? And if you like, you can define God to be the answer to that question. And I find this very interesting because Stephen Hawking, often in the press, is viewed as an atheist, right? But really is not. That's why I'm quoting directly. Because some people, if they think some really bright person, like the Einstein of the 21st century, thinks about something, and who studied it a lot, he's created discoveries and so on, wow, that guy must be awesome, right? So, okay, that opinion, he's the Einstein of the 21st century, right? What did Einstein think about this whole thing? Which, by the way, some of these were already starting in his time, but he did not live long enough to see the flowering of astrophysics. Okay, and Einstein is always being asked, are you a pantheist? Are you an atheist? Blah, 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 you believe in God? Blah, blah, blah. So he finally said, he was kind of trying to clarify because people were misquoting what his position was, and he said, I am not an atheist, and I don't think I can call myself a pantheist. Okay, so I don't think I can. You know what pantheism is? Okay, a spirituality in nature. You know, nature is pervaded by spiritual forces and beings and realities and so on. Okay, then he makes a little comparison. We are in the position of a little child entering a huge library filled with books in many languages. The child knows that someone has written those books. It does not know how. It does not understand the language in which they were written. But the child dimly suspects a mysterious order in the arrangement of the books themselves. Okay. That, it seems to me, then Einstein commenting on that story or that picture, is the attitude of even the most intelligent human being toward God. We see the universe mysteriously arranged and obeying certain laws. By the way, there are only 6 laws that astrophysicists have covered that you can create universes out of. But only dimly understand these laws. Our limited mind grasps the mysterious force that moves the constellations. So obviously, Einstein himself was working on a certain perspective of the universe, and Stephen Hawking. And so now, there is a Nobel Prize winner, a physiologist. He also won the Nobel Prize. And he now brings into a fuller expression what is implicit in these statements, aside from the external discovery that the universe is improbable, our current universe. So George Wald, a physiologist and Nobel Prize winner, said, mind, rather than emerging as a late outgrowth in the evolution of life. Okay, he is one of those who made a lot of studies on how tried to create life, right? His mind has always existed as the matrix. In other words, it's the overall context, the source and condition of physical reality. That the stuff of which physical reality is constructed of is mind stuff. That will explain why there is mind and life in the universe. It is mind that has composed a physical universe that breeds life, and so eventually evolves creatures that know and create science, art, and technology making creatures. So you can see now what was the underlying assumption of science itself, of doing science itself, the presupposition of rational laws in nature and in the universe. And of course, natural evolution also presupposes that, the law of natural selection, right? And the neo-Darwinism all presume these laws. So now, why is it like that? Why is the universe a reality like that? Because basically, reality is mind stuff. And out of that mind stuff, which is the matrix, physical reality emerges. It's the opposite of what most people tend to believe, right? First is physical, and then life, and then consciousness, and then thinking, reflection, self. It's the opposite path. Basically, if you want to picture it like this, if this is the evolutionary path, yeah. So at certain critical stages of natural evolution, certain aspects of this mind, which we know as life, if the physical vehicle has been constructed to a certain kind of complexity to hold life, then another principle is able to enter there. Okay? But also coming from mind. So consciousness had to build its own vehicle, instrument, to actually exist consciously on this planet. I mean, I'm just talking about if you were going to take this path of theistic astrophysicists, that's how it's going to look like. And therefore, as you can see, it's becoming very closely associated with the spiritual science of Rudolf Steiner, right? It's a very clear thing. That's why Steiner himself kept saying that true spiritual science has nothing to fear with authentic natural science. If scientists, I'm just now explaining now. If scientists truly stick to the facts and the evidence and just be continually led by the truth of it, they will start seeing that we live in a spiritual universe. And I'm going to draw out this implication further. What does it mean to have AI in an intelligent universe? It's very important because this is not about whether we have AI or not. We're going to have AI. That is very clear. But the question is, what kind? So I'm sort of I'm sort of giving a glimpse of what moral technology is, right? Which I will draw out. So before we could really understand moral technology, we had to go through a whole set of many different paradigms to understand what it is in terms of embedded thought that we are programming in the AI, because programs, algorithms are nothing but thought, encoded languages, specific languages that are giving instructions to the machine, how they should function. So the question is, what kind of thoughts are we putting there? Because the kind of thoughts we're putting there will create the kind of machine that actually emerges. So if the thoughts are incomplete in terms of the picture of what really reality is, or what life is, or what consciousness is, we're getting a certain kind of intelligence, but it's not, in a sense, only part of human intelligence. Because human intelligence is much more vast. The fact that we could create artificial intelligence shows that we have this creative power in us as a result of evolutionary processes. to actually spin off an aspect of ourselves. Okay, this is important because what are we spinning off? You know, scientists call this, scientists of technology or philosophers of technology, call this exosomatic evolution. Exo, soma, cell, outside the body. Technology, we are spinning off technology. If you take the backhoe, it's nothing but an elaborated hand, right? The tractor plow is nothing but sophisticated hoe. See what I'm saying? So internet is the externalization of the nervous system, which now encompasses the planet. So there is a kind of exosomatic evolution of technology, and AI is the latest and the most powerful. So the question is, especially in connection with moral technology, what are we externalizing? The fact that we can externalize shows that there are deeper powers in us, that much deeper than we have realized. Because that, in fact, that we can question what are we externalizing shows that there is a certain aspect of ourselves that can still see this process and still make decisions. It's not fully encompassed in the process of externalizing. Otherwise, the whole process will be unconscious. So AI is only an aspect of the real creative powers that are in us. And by the way, the way machines function now, as I already said, it's a human, creative human-machine hybrid. The algorithms are produced by humans. But the point has come that these algorithms are becoming so complicated, the humans have designed machines to create programs. Okay, this is where part of the safety problem now comes in. Part of the safety problem is that both in the hardware and in the software, no single human can encompass the complexity of these codes. You know, in the old days, did you know how they designed microchips or microprocessors that are present in your computers or in your cell phone? The engineer would literally, okay, this is one description out of Silicon Valley. You would actually lay out in a room, a paper, and then you will go through all the on-off switches, the switches, the digital coding, one by one, in the microprocessors, you're going to trace how that's going to look like, how it's going to respond, all on the paper, and then you reduce the size, keep on reducing the size until finally you imprint that, engrave that into a silicon crystal. It assumed that the designer had an overview, okay? But now computer hardware is becoming so complex that they've reached the point in the mid of the 21st century, maybe 2004, 2005, where humans were no longer able to encompass the complexity of both the software and the hardware. This is the reason why they don't report too much the failures of software, because they've been trying to fix bugs in the software for a long time, and it's becoming more and more complicated. So you got modules, subprograms, programs, subprograms, modules, and so on, all down the line. And you are focused on one area, you're hoping that your colleagues are also focusing on another area, and all of this will match together, right? Well, unfortunately, in the history of technology, there have been failures in rockets, in hospital technology, people getting radiation treatment, dying because they were overdosed because of a certain line of code, gave them a higher dosage. Okay, the software glitches. And so, you know what, it became so complex that somewhere maybe 10 years ago they said, okay, let's not try to create a perfect software. Okay, so that's really already a problem in itself. Let's not try to create a perfect software. Let's just deal with it When it fails, we just fix it. Common kind of attitude is too complex. So the final solution would be to bring in an AI to start checking the code, right? You know, in the United States, in 1 year alone, they spent $400 billion just checking the code, if it's accurate or not. Huge amount of human thinking. But there's a kind of problem, a kind of glitch. The software, the AI, is like saying, the software will check the software, right? Okay, so now if the software that you created to check the software is itself problematic, then it will not really be able to check. Okay? This is why Microsoft, I already mentioned this, 46 million lines of code, and experts have found 1 million gaps. That's why the favorite hack is on Microsoft, and there are a lot of viruses they're developing all the time. And by the way, the picture of the Mac, or the operating system of Apple, as invincible to viruses, is finished. No, it's finished, it's gone. Because it's been hacked. Yeah. So, okay, so what all I'm trying to just say on the safety side of the current status is now both software and hardware are so complex that not one human being can hold the picture of the system as a whole. And that's why there have been many technological glitches costing lives and billions of dollars of destruction that have not been reported. But sometimes, if you reach the technological journals, then you see it there. Okay. So, anyway, that is just a beginning of the moral tech side of this whole thing, where it's going. And the question is, ultimately, mind, basically our thoughts in this case, what kind of thoughts are we going to immortalize in our AI? Will it be a picture of the universe which is not accurate? Or a picture of the human being which is incomplete? Or will it be a picture that encompasses the understanding of where the universe was going? You know, but do you know the reason why scientists really hate the anthropic principle in a sense? Because if there was design, if there was conscious planning, all of these things, therefore that design had a certain objective. Yeah? So in other words, evolution was directed. It was not left up to chance. Until the point where the creation, so human freedom emerges there. So the point has come where the design is now transferring to us. And so the question is, how are we going to design the machines of the future if we have no understanding what the universe intended the world to be? For example, like just mentioned the case of we value our freedom a lot, but there's not too much emphasis on responsibility. That's just one end. But ultimately, where does freedom end? Because some people would say that it would end in the capacity of really being able to love. Yeah? We cannot love if we're not free, because we are determined from various aspects of our organism. We cannot truly love. Love presupposes freedom. You can't say to somebody, I love you because my gonads are starting to act up, right? Or my hormone is starting to... you won't even say that because you're not aware. Anyway, so you get the point, I guess. The moral comes from, okay, I'm just going to say this. In spiritual science, there's an exercise. It's called looking at the essential and the non-essential. Every night, what did you do in your day that was essential, non-essential? I found out that I could not do that exercise until I understood where the universe was going. Because most of the time, we do that exercise out of egotistic purposes. And therefore, if it's really egotistic, it's really non-essential as far as the universe is concerned, right? So I really couldn't do the exercise. So I was, until I set a certain understanding where it's going. I mean, not complete, but just where this whole thing has been leading. So one clear aspect is the emergence of clear reflective thinking, autonomous thinking. It created the autonomous, clear, living thinking. That is towards the end of this process, and this is where we are now. Because otherwise, if we were born here earlier, just around here, we would have been spiritual automatons. Okay. Yeah. So if we did not rise beyond being spiritual automatons, then we could not be free, and we could not really create artificial intelligence. We can create artificial intelligence because we're free. Anyway, the time for this period is finished, and we'll take a break. Like I was saying, 20-minute break, and then we'll come back. Thank you.